Trigonometric equations. This is a practice problem set, which is the best way to study this topic, in fact, because every problem is different. This is not going to be something you can memorize a pattern and be able to solve all the trig equations. Now, trig equations will require everything you know about solving algebraic equations. It will require knowing trig identities, and it will require knowing what the restrictions on trig functions are, such as sine theta equals 3 is impossible. So if you get something out of range, that contributes no solutions. You also want to know that the trig functions are cyclic and how the cycles occur. Okay, so we're going to take a simple one to get started, and they won't all be like this. We're going to find all solutions to 2 sine theta plus 1 times sine theta minus 2 equals 0. Well, as soon as you see the problem, the solution is about to come. So if you want to try these without seeing the solution, which is the recommended way of studying math, you would want to pause, solve, and then continue. Okay, so we have 2 factors equal 0. The rule in math is that if I have a product of 2 numbers that are equal 0, then one of those factors is 0, at least, maybe both. And so I'm going to set the first factor equals 0, the second factor equals 0, and get my solution set. So setting the first factor equals 0, 2 sine theta plus 1 equals 0, gives me 2 sine theta equals negative 1. Sine theta equals negative 1/2. Well, the sine is negative 1/2 in the third and fourth quadrants. And our reference angle for sine theta being 1/2 is pi over 6, so it would be 7 pi over 6 and 11 pi over 6 is our 2 solutions. Plus, in each case, 2n pi, and the reason for that is we can go around the circle more than once. And how many times we go around? This is an integer. N is an integer. I'm not saying positive integer. It can be negative. I can go backward. It can be 0. The other factor, sine theta equals negative 2, sine theta minus 2 equals 0 gives me sine theta equals 2. Gives me no additional solutions. So the red up here is my whole solution set. Find all solutions of 2 over the tangent theta plus 1 over tangent squared theta equals negative 1. We need a least common denominator. Look at this, I would realize it's tangent squared. So tangent squared would give me a tangent beneath right here behind the 2. So it's 2 tangent theta plus 1 over tangent squared equals a negative 1 times tangent square over tangent square, because I want to make everything over the common denominator. Then one trick from algebra would be to take the numerator and find its solutions, because all the zeros from the numerator are going to be my solutions. So the tangent squared theta, which comes from right here, bring it over, it becomes a positive. plus 2 tangent theta plus 1 equals 0, which is the tangent theta plus 1 equals squared equals 0. Well, that's just going to give me repeated solutions. So where's the tangent plus 1 equals 0? Where the tangent is negative 1. Where's the tangent negative 1? In the second and fourth quadrants. So they're going to be pi apart. So I can collect them and just make it plus n pi. It'll be 3 pi over 4 plus and the 7 pi over 4. So I'll pick all my solutions. So I'm writing it a little more concise like this. Okay, now find all solutions to secant theta plus tangent theta equals 0. One little trick in solving trig equations is when you have different functions, if you go to sines and cosines, it often really helps. So the secant is 1 over the cosine. The tangent is the sine over the cosine. I have a common denominator, so I will set the numerator equals 0. So I get the sine theta equals negative 1. Where's the sine negative 1? That's at 3 pi over 2. But this is where the denominator cosine 3 pi over 2 is 0. So I do have to look at not being in a situation where I'm dividing by 0. That would cause me to divide by 0. So this equation has no solution. All my solutions are going to be at points where I have a division by 0. That's how this one happens to be. And so just like in math, algebra, you don't always have to have a solution. This is a no solution problem. The next one, find all solutions to 2 sine squared theta minus 1 equals 0. Well, 2 sine squared theta equals 1. Sine squared theta equals 1/2. So the sine of theta equals, and this is very important, when I take the square root, I have to take both, the positive and the negative. So I get solutions where the sine of theta is 1 over the square root of 2, and where it's negative 1 over the square root of 2. Or rationalizing a denominator, put it in the form you're more familiar with, the square root of 2 over 2. So where's the sine square root of 2 over 2 at pi over 4? And since I'm picking that up in each quadrant, because I have the positive and the negative, and that happens to be 45 degrees. If it was not 45 degrees, I would have to deal with each sign, SIGN sign, separately. I get theta equals pi over 4 plus n pi over 2. Find all solutions to 2 sine squared theta plus 3 sine theta plus 1 equals 0. Well, here we have a factoring problem that factors 2 sine theta plus 1 and sine theta plus 1 equals 0. Or 2 sine theta plus 1 equals 0, which means 2 sine theta equals, or sine theta equals negative 1/2. That will give me solution 7 pi over 6 and 11 pi over 6 plus 2n pi. Sine theta plus 1 equals 0 gives me sine theta equals -1, which gives me 3 pi over 2 plus 2n pi. Okay, so all of the red solutions must be included. Number 6. Find all solutions to the tangent squared theta plus the tangent theta equals 0. We would factor out tangent of theta times the tangent of theta plus 1 equals 0. A tangent theta equals 0 at 0 and every n pi from there, so it's 0 plus n pi. A tangent theta plus 1 equals 0 is where tangent of theta equals -1, which is going to be at 3 pi over 4 in that's the third quadrant. And we'll also have the fifth quadrant, so it's going to be plus n pi, not 2n pi, because this is 45 degrees. So we can pick those two numbers up and they will look a lot alike. Okay, find all solutions to sine theta cosine theta equals 1/4. Okay, now that's starting to look a little different. 2 times the sine theta cosine theta equals 1/2. That would be by multiplying by 2. Well, why would I multiply by 2? Because I recognize 2 times sine theta cosine theta. I recognize that form from an identity to be the sine of 2 theta. So the sine of 2 theta is 1/2. So 2 theta is pi over 6 plus 2n pi. And 5 pi over 6 plus 2n pi. So theta, you have to solve 2 theta for theta, is pi over 12 plus half of 2n pi is n pi, and 5 pi over 12 plus n pi. So these are my solutions. Yes, the double angle formulas are legitimate, and you have to use them if the situation requires. This would be very difficult to solve otherwise. When I was playing chess one time, and I took a pawn en passant, my opponent looked at me and said, "I didn't know we were playing by all the rules." Well, yes, we were. And in this case, we're playing by all the identities. So we can't ignore identity. Find all solutions to cosine squared theta minus sine squared theta equals 1. Cosine squared theta minus sine squared theta is the cosine of 2 theta. So we have the cosine of 2 theta equals 1, which means that the cosine is theta at 0 and at n pi. So 2 theta equals 0 plus n pi, or theta equals 0 plus n over 2 pi. Find all solutions to 2 cosine squared theta plus sine squared theta equals 2 cosine theta plus 4. Well, here we have a mixture of cosines and sines, and it looks like it would be a nice quadratic if we could just make it all cosines. Well, we know that sine squared plus cosine squared equals 1. So I can replace the sine squared theta with 1 minus cosine squared theta. So 2 cosine squared theta plus 1 minus cosine squared theta equals 2 cosine theta plus 4. Combining like terms, I get cosine squared theta, and bringing things to one side, minus 2 cosine squared, cosine theta. And this becomes 1 minus 4, negative 3, and that's equals 0. So we're going to factor cosine theta minus 3 and a cosine theta plus 1 equals 0. Well, the cosine cannot be 3. So our solutions are going to come from cosine theta plus 1 equals 0, which is cosine theta equals negative 1. And that's going to come at pi plus every 2n pi. So find the solutions to sine squared x plus 2 sine negative x equals 0. Well, sine is an odd function. So an odd function tells us that since the sine is odd, the sine of negative x equals negative sine x, or the sine of negative theta equals negative sine theta. So now I have sine squared theta minus sine theta equals 0. Sine theta equals 0, and sine theta minus 1 equals 0. When sine theta is 0, I'm getting solutions at 0 plus n pi. And when sine theta equals 1, I get solutions at pi over 2 plus 2n pi. Well, thank you for watching, and I hope you will hit the subscribe button before you leave. Thank you.